Hi, hello, my dear children. How are you? I hope all of you are staying safe. Today we are going to start a new chapter, Polynomials. That is chapter number 2. Okay, and first we are going to answer the introduction. And you have learned about polynomials in 9th standard elaborately. So we'll just recall, let us have a small recap and we'll move to the 10th portion. Okay, so in this session I am going to recall all the details you have studied about polynomials. Okay, let us join together. So the first one, introduction. In the introduction, first we are going to recall what is an algebraic expression. Okay, so the algebraic expression is a constant. Each term of the algebraic expression should be what? A constant into variable or variables. The whole power a real number. Okay, so this is a particular term of an algebraic expression. Okay, so the term should contain a constant. The constant may be what? 0 or 1, 0 no need, but 1, 2, 3, 4, 5 or root any real number. Constant may be any real number. It may be a negative or positive or fraction or rational or irrational. Okay, and the variable, which the term, each term may contain a single variable or double variable or triple variable. But the power should be a real number. Real number means it includes all positive numbers and negative numbers. It includes zero fractions, rationals and irrationals together. Okay. So example, 3x square y plus 5 root x plus 7y square. Okay, so this expression has 3 terms. Okay, and when you take this first term, a constant into a variable x and another variable y. The power is here 2, here 1. So both are real numbers. And when you take this the second term, a constant into only one variable, but the power is what? It is 5x power half. Okay, so this is 3x square y plus 5x power half plus 7y square. Isn't it, children? So next I will give another example. 7y x square plus 5yx minus 3y. Okay, so this is what actually 3 into x power minus 2 plus 5 into x power minus 1 plus suppose you have root y, 3 into y power minus half. Okay, children? So 5x power minus 1 minus 3 y power minus half. Here this one variable, here another variable. And see the power, it is minus 2, it is minus 1, it is minus root 2. Minus 2, minus 1, minus half or what? Real numbers. Okay. So it may be, you may have root 5x square minus 3 y square. So you may have a coefficient root 5 also. This is the algebraic expression. Okay. Now, let us move to what is a polynomial. And what is the difference between a polynomial and the algebraic expression? Here we are going to deal a polynomial with only one variable. Okay. And the polynomial should be, each term of the polynomial should be what? A constant into only one variable. Okay. Only because we are going to deal with a variable. The whole power, a whole number. That means the power should be only whole numbers, that is 0, 1. From 0 it can have. It should not have a negative power. It should not have a fractional power. That is the main condition for the polynomial in one variable. And each term of the polynomial should have only one term. The same term. If you write a polynomial, the same term should be in the polynomial. Okay. And the polynomial, each term of the polynomial should be written in the descending order of the powers. Okay. So these are the conditions for an algebraic expression to be a polynomial. Polynomials are also algebraic expression, but they have some strict conditions. They should follow that. Okay. Now I will give an example. 7x plus 9. It is a polynomial. Here the degree of x is 1. Here 9 means x power 0. Okay. And minus 11x square plus 3x minus 9. Here we have what? All real coefficient, the coefficients of x square, x, and the variables may be a real number, but the powers only whole numbers. Okay, the powers should be only whole numbers. Here the power is 2, here the power is 1, here the power is 0. 2, 1 and 0. They are whole numbers. Next, you may have 3x cube plus 5x square minus 2x minus 1. See here, all terms have the same variables x, x, x. And suppose they have, if you are writing another polynomial, y square minus 2y plus 3. So the variable is y. Here it is y power 0. Here it is x power 0. So the powers are 3, 2, 1 and 0. Have you understood, children? Here 2, 1 and 0. So this type of algebraic expressions are called polynomials. Have you understood what is a polynomial now? Now next, degree of the polynomial. And the degree of the polynomial is the highest power of the variable in it. Variable. Now if you take this polynomial, here the degree is 1 and it is written in the descending powers, 1 then 0, isn't it? And here in this one, the highest power is 2. So it is, the degree is 2. Okay. and here the highest power is 3. So the degree is 3. And here the highest power is 2. So degree is 2. So this is the degree is 1, here degree is 2, here degree of this polynomial is 3 and degree of this polynomial is also 2. Have you understood, children? So degree of the polynomial is the highest power of the variable in the polynomial. Okay, and the polynomials are denoted by P of x. That means P of x means what? Polynomial in the variable x, or polynomial with the variable x, or polynomial of the variable. Okay, here P of y or Q of y also you can write. It's what? Polynomial with variable what? Y. Have you understood, children? This is the way we are denoting the polynomials. Now, next is naming, name of the polynomials. We can give special names to the polynomials according to that degree. Okay, so if the degree of the polynomial is 1, it is called as a linear polynomial. If the degree is 1, it is what polynomial? Linear polynomial. If the degree is 2, it is called as quadratic polynomial. If the degree is 3, it is called cubic polynomial. If the degree is 4, it is called fourth degree polynomial. Okay, if the degree is 5, fifth degree. If the degree is n, it is called as nth degree polynomial. Is it clear, children? And now, for linear polynomial, we can write example 3x minus 5. P of x is equal to. And here for the quadratic polynomial, you can write P of y is equal to x squared plus 7x minus 5. For that, for degree of this degree is 3, you can start with x cube minus x plus 5. You can write like this. If the x squared is missing also, no problem. The coefficient of x squared is 0, you can take. For nth degree polynomial also, we can write fourth degree polynomial also. It will start with x power 4. Nth degree polynomial will start with x power n. Okay, children. Now, let us next move to general form of the polynomials. Okay. So, for the linear polynomial, the general form is always we will write the polynomial with the coefficients a, b, c. Okay. So, general form of linear polynomial. General form. For For linear polynomial ax plus b, a should not be equal to 0. If a is 0, this term will become 0, so you will have only b. So then it will not be a linear polynomial because the degree of the variable will not be 1. If the degree of the polynomial is 1 only, it is called as linear polynomial. And here for quadratic polynomial, ax squared plus bx plus c. Condition is what? A should not be equal to 0. The coefficient of x squared should not be 0. And for cubic polynomial, ax cube plus bx squared plus cx plus b. Okay, for fourth degree it will be ax power 4 plus bx cube plus cx squared plus dx plus e. Okay, for nth degree polynomial, an x power n plus an minus 1 x power n minus 1. Like that we will write the last term will be a 0. Okay, an minus, these are all coefficients, numerical coefficients. Is it clear, children? So this is the general form of the polynomials. Next one, value of p of x at x is equal to k. Suppose you want to find the value of the given polynomial for a particular value of the variable x. Okay. See here, suppose you have a polynomial x is equal to x plus 3. So if you want the value of the polynomial at x is equal to 1. Okay, I am going to find value of the polynomial px at x is equal to 1. So in the place of x, you will write 1. So polynomial, the value of the polynomial, what is the meaning of this? Value of the polynomial at x is equal to 1 is equal to, in the place of x you write 1 plus 3, that is equal to 4. In the same way, if you want to find the value of the polynomial at x is equal to 2, it will be 2 plus 3 is equal to 5. Okay, like that you can find the value of the polynomials for a particular value of the variable. Okay, now next one is 0 of the polynomial. Zero of a polynomial is the value of the variable x, or if the variable is y, value of the variable y. Okay, at which the value of the polynomial p of x become 0. Okay, 0 of a polynomial is the value of what? X. That makes the value of the given polynomial 0. Okay, so suppose you have p of x is equal to x minus 7. So at what value for x it will become 0. So if you write p of 1, it is 1 minus 7 minus 6. If you write p of 2, it is 2 minus 7 minus 5. If you write p of 3, it is 3 minus 7 minus 4. If you write p of 4, 4 minus 7 minus 3. Like that, if you write P of 7, what? 7 minus 7, 0. So, 0 of P of x is what? X is equal to 7. So, at the value of x is equal to 7, the value of polynomial becomes 0. So, the value of x makes this polynomial 0 at x is equal to 7. So, x is equal to 7 is called as the 0 of the polynomial. So, like that you can find the 0 of the polynomial for all the linear polynomial, for the quadratic polynomial, cubic polynomial, for all the polynomials. Okay. Now, how many zeros each polynomial can have? If it is a linear polynomial, it can have only one zero because the degree is 1. Okay, at most it can have 1 0. If the depends upon the degree of the polynomial. The number of zeros depends upon the degree of the polynomial. If the degree is 1, it will have only 1 0. At most, it can have 1 0. If the degree is 2, it can have at most 2 zeros. If the degree is 3, at most it can have 3 zeros. Okay, if the degree is n, it can have n zeros. That means if the degree is 5, the polynomial will have 5 zeros at most. Have you understood, children? So, this is the these are the introductions for the polynomials. All these things you have studied in 9th standard. How to find the 0 of a linear polynomial and quadratic polynomial also you have studied. Okay, but in 10th standard, you are going to learn the geometrical meaning of 0 of a polynomial. Okay, what is the geometrical representation of linear polynomial, quadratic polynomial, cubic polynomial in the graph sheet? Already you have studied 9th standard the linear polynomial, the geometrical representation or the graphical representation of a linear polynomial is a straight line, isn't it? So, here you are going to learn about the geometrical meaning of the 0 or zeros of a particular polynomial. But you are not going to draw. Okay, and next one, you are going to study the relation between the coefficients of the polynomials and their zeros. That's all for this academic year 2020 to 2021. Division algorithm is not included only for this year. Okay, children. So you have only exercise 2.1 and 2.2 for this year public examination. I will study the geometrical meaning and the relation between the coefficient and the zeros of the polynomial in the next session. I think you might have understood, you might have recalled the meaning of the polynomial and everything. Algebraic expression, polynomials, degree of the polynomials, naming, general form, value of the polynomial, zeros of the polynomial. Okay, children. Thank you, children. God bless you. Take care of your health, which is very, very important now.